Good day. We are from ABM 11-2 and we are about to give you tutorials from the topic composite function. So what is a composite function? A function whose values are from two given functions by applying one function to an independent variable and then applying the second function to the result and whose domain consists of those values of the independent variable, for which the result yielded by the first function lies in the domain of the second.
Problem number 1. For the first problem, we need to find E composite K of X if E is equals to 7X plus 5 and K is equals to 3 minus 3X. E of K of X is equals to 7X plus 5. We'll substitute the value of X. So 7 times 3 minus 3X plus 5, that will be equal to 21 minus 21x plus 5. Combine like terms, so the final answer will be E of K of X is equals to 26 minus 21x. Problem number 2. For this problem, we need to find S composite J of 7 if S is equals to 4 plus 6x and J is equals to 9x minus 4. S of J of 7, so we need to first solve the J of 7, so that will be J of 7 is equals to 9x minus 4. We'll substitute the value of x, so that will be 9 times 7 minus 4. That will be 63 minus 4. J of 7 is equals to 59. S of J of 7 is equals to 4 plus 6x. So we'll substitute the value of x from what we get on J of 7. 4 plus 6 times 59, that will be equal to 4 plus 354. S of J of 7 is equals to 358. Problem number 3. We need to find G composite M, composite J, composite S of 3. If G is equals to 2x, M is equals to 5x plus 3, J is equals to 1 plus x, and S is equals to 6x. G of M of J of S of 3. We first need to solve S of 3 since it is in the inner part. S of 3 is equals to 6x. 6 times 3. So S of 3 is equals to 18. Next, we need to get J of S of 3. We'll substitute the value of x from what we get from S of 3. J of S of 3 is equals to 1 plus x. So that will be 1 plus 18. J of S of 3 is equals to 19. Next to find is m of j of s of 3. That will be 5x plus 3, and we'll substitute the value of what we get from j of s of 3. That will be 5 times 19 plus 3 and 95 plus 3. M of j of s of 3 is equals to 98. For the last, g of m of s of j of s of 3 is equals to 2x. 2 times 98, that will be g of m of j of s of 3 is equals to 196. Fourth and the last problem. For the last problem, we need to find A composite D, composite A, composite D, composite A, composite D of X. If A is equals to 3x and D is equals to 2x minus 1. We'll first solve A of D of x since it is in the inner part. So 3x will substitute the value of x. So 3 times 2x minus 1. Then distribute. That will be 6x minus 3. Next to find is T of A of D of x. So that will be 2x minus 1, 2 times 6x minus 3 minus 1. D of A of D of x is equals to 12x minus 7. Next is A of D of A of D of x. That is equals to 3x. So 3 times the quantity of 12x minus 7. That will be 36x minus 21. Next is D of A of D of A of D of x. Two x minus 1, and we'll substitute the value of x. 2 times the quantity of 36x minus 21. And minus 1. So that will be 72x minus 42 minus 1. D of A of D of A of D of x is equals to 72x minus 42. A of D of A of D of A of D of x is equals to 3x. We'll substitute the value of what we get from D of A of D of A of D of x. That is 72x minus 42. 3 times the quantity of 72x minus 42. That will be 216x minus 126. So A of D of A of D of A of D of X is equals to 216x minus 126.